All right, guys. Hello and welcome to lesson 10.2, part 1. And here we talk about the area of a trapezoid. Okay, so there's a couple different ways you can do an area of a trapezoid, but there is one formula that you can use and it'll work all the time. There are some things that you need to know, the anatomy, if you will, of a trapezoid. Hopefully you understand that the sides that are parallel are referred to as your bases. Now, remember, this is not meaning that when every side that's like here is the base. Even if I turn the figure, the sides that are parallel are called the bases. So it's what's parallel, it's not what you see, okay, or how you see it. For example, most of you, if I showed you this, you would say this is the base, okay? All right, but look at it sideways, you can see that it's a trapezoid. This and this are both bases, all right? They're the sides that are parallel. These sides are not. This would actually be an isosceles trapezoid. So these are the types of things that you see around all the time, but you don't really call them names or recognize them. You would just say, oh, well, that's a basket, okay? So we're going to find the height of a trapezoid, which again, we're focusing on this mark. Now, as a hint, this mark will tell you what the bases are because it's connected to them. The formula for the area of a trapezoid is a little different. Okay. Now, I write it differently than the book, but it's written as 1/2 height base 1 plus base 2. Okay. Personally, I write it as height base 1 plus base 2 divided by 2. Why? Because they're the same. Okay. Both of these are the same. Hopefully you know when you multiply by 1/2, it's the same as dividing by 2. So if you see them in different books written different ways, I want you to understand that they are the same. This is also very similar to the mid-segment formula, right? The mid-segment formula was just base 1 plus base 2 divided by 2. There's no height involved, okay? Well, now we're finding area, we have to include the height. This is when we start getting into many of our right triangle work, because you should be able to see that there is a right triangle that's made with the two bases. Now we're just going to try a very basic problem. Okay. Here's the basic problem we're going to do. Okay. We know that there's 309 miles in the state of Nevada. Okay, this is supposed to be what the state of Nevada looks like, 309 miles. We know that one border is 511 miles. We know the other border is 205 miles. Okay? So when we're doing this problem, here's base 1, base 2. This is my height. Notice it's turned sideways. So we put into our formula 309, 205, plus 511, all divided by 2. And if you have your calculator, the calculator you're supposed to have, this becomes very easy because you literally type in exactly as you've written. This is why I tell you, write out the formula, plug in the numbers, then put it in your calculator, because it's a way of double checking your work. If you come up and you get the wrong answer, 9 times out of 10 it's either a calculator mistake, you push the wrong button, and you can never tell. Well, with our calculators you could, because it keeps what you've typed in on the screen. So you can double check it and make sure your work that's written there is the same thing you've typed into the screen. All right, so when you do that and it's simplified, that means we do all the math. You end up with a long decimal, 110.622. So it's 110 miles squared. Why? Because this is an area. All right, now, where do things get a little tricky? being able to work forwards and backwards. One of the other reasons why I want you to write out this formula is because they may give you two of these three pieces and then give you the area. If they give you the area, then you're going to be working backwards. You still write out the same problem. So let's just say I have a trapezoid. Now I'm doing this one, and I'm letting you know that the area is 500 feet squared. And base 1 is 37. And I'm even going to give you the height of 50. I need to know what base 2 is. Alright, so what's wrong with this one? I'm missing the other base. So I have to write out area equals height base 1 plus base 2 divided by 2. And now I plug in all the numbers I have. I have 500 feet squared. I have the height of 50. I have one of the bases, but I do not have the other base. So I put x and then divided by 2. And then from this point on, this is where your algebra skills are supposed to come into play. Okay? You're supposed to know how to work backwards. It's PEMDAS backwards, which means when you see parentheses, you're not going to do that first, you do it last. So I get rid of my division and multiplication first. So I'm going to multiply both sides by 2. When I multiply both sides by 2, this becomes 1,000. And this is now 50, 37 plus x. Now I'm going to divide both sides by 50. Okay, and the reason why I'm dividing by 50 is I need to get rid of this 50. So when I divide by 50, I then get 20 equals 37 plus x. Okay, now I can get rid of the 37. And who can tell me what's going to be wrong with this problem? Correct. This is impossible to happen because you're going to end up with a negative x, which means your base would be a negative measurement. Is that possible? No. Now, I'm just doing this to show you the math. I made my numbers up. This would not be possible only because if I minus 37, I get negative 17 equals x. That's impossible. This base can't be negative 17. All right? So in other words, this would not be a trapezoid. It doesn't exist. Could they give you questions like this? Of course they can. Okay? They do that with triangles. Does this triangle really exist? And you know that if you add two of the sides, the two smallest, they must always be bigger than the third side. And if they're not, then it's not a triangle. So just because they give you three measurements doesn't necessarily mean it is the shape they say it is. All right, so understanding what kind of algebra you may see if they give you the answer and having to work backwards, and understanding what your answer means are really important in this section. All right, so let's move on to the next type of problem. The next type of problem you can have would be when we have to use our right triangle work. Yes, I know, some of you are grizzling. You're like, ugh. Right, because you did so fantastic in chapter 8, many of you are stressing because you're not sure how to do right triangle work. So here we go. The key that you're doing right triangle work is that they will give you that measurement, 60 degrees. Now they're not going to give it to you for your health. They're trying to tell you that this is what type of right triangle, meaning I have to add the height in this picture. Okay, so when I add the height, you should know what type of right triangle that is. Hopefully you've already said in your head a 30, 60, 90 triangle. The other special right triangle is a 45, 45, 90 degree triangle. Now they give you those measurements because you're supposed to find the height or pieces of the base by doing that special right triangle work. Hopefully remember that in a 45-45 90-degree triangle, we always try to draw it like this, and then the square root of 2 is on the hypotenuse. In the 30-60 90-degree triangle, we always try to put the 30 up top, right? And then you have 2 and the square root of 3. When we go down, you divide. When you go up, you multiply. So you have to manipulate your picture. If you need to, you can just turn your picture so that your 30 is up top. And then put the measurements. That would be the hypotenuse. This would be the long side, and this is the short side. Well, why? Because 60 is always across from the longer side. 30 is always across from the shortest side. And of course, the hypotenuse is always across from the 90-degree angle. All right. So here they've given you a measurement. And here they've given you a measurement. And when you look at this, when I've added that height, can somebody tell me now what this piece right here, this measurement, would be? I'm going to give you a second to think about it. Now I'm going to give you a hint. The 5 meters has something to do with how I figure out this little piece. Well, now I'm hoping you've done 7 minus 5, because this distance and this distance are the same. So this must be 2. So what do? I tell kids, separate the triangle work from everything else. And when you separate the triangle work, you're going to know, oh, well, this is 2. And that's the small leg, right? Because 30 is up here. So that means everything else I'm going to get by multiplying. If I needed to find the perimeter, I would need the hypotenuse, but I don't. I know the hypotenuse is 4, but I don't really need it. I need this right here. This is 2 square root of 3. Now, how do I know that? Because when I go up to find the longer leg, I multiply by the square root of 3. So 2 times the square root of 3. So on this picture, I now know the height is 2 square root of 3. And now I can do my area formula. Okay. And again, you can put it in your calculator just as you see, and it will give you an answer in simple radical form. Now, here's the catch. A lot of your answers are going to be in simple radical form. Many of you have still not gotten the correct calculator that'll put it in simple radical form. So you're going to have to remember how to do simple radical form or buy the calculator. My suggestion is, from this point on, for the rest of the year, that calculator is used heavily in every section. In this section, in section 11, and in section 12. We do nothing but sine, cosine, and tangent. We do nothing but right triangle work, lots and lots of right triangle work. My suggestion would be making sure you have that calculator. All right, so when I go through the motions, you should have ended up, those of you who've used your calculator, yes, you should have ended up with the area equals 12 square root of 3. And then you'd have to put meters squared. All right? Okay, good job. I'm going to now give you the got it problem. So you're going to do the got it problem 1. I'll show it to you. Okay. There's got it problem 1. Pause it. Do the problem. Then I'm going to check your answers. We'll check the answers in a second. Okay, there's got it 1. Okay, and now we're going to do got it 2. Again, pause your video, do the math work, and then we'll check the answer. All right, hopefully you've gone ahead and finished got it number 1. And I will do it with you. Okay, it's a trapezoid, so I draw a trapezoid. Now, it doesn't matter what your trapezoid looks like. Heck no. Okay, as long as you know it's a trapezoid. and then they say that the height is 7. Okay, so I know my height's 7, and it says the bases are 12 and 15. So I've drawn my picture, I've got everything I need, so height times base 1 plus base 2 divided by 2. And again, I need to see this, I need to see this, and then you can give me the calculator answer. I have to see these two things at the minimum. If you're not going to draw out the picture, that's fine. Later on it could get confusing, but it's okay. But you do need this formula written, then the plug-in, then the answer. For you to get credit for your work, you have to show those things. Okay? So hopefully you know that that's 27, right? So 27 times 7 divided by 2. Correct. You should have ended up with 94.5. Did anybody forget the rest? Yes, centimeters squared. Okay. Good job. And we move on to got it number 2. Okay. The second got it said the angle inside our triangle is now 45 degrees. Okay, so now they're telling us that this measurement here is 45. And they want to know the height. Well, does that change this at all? No, the bases are the same. So this would be 5. This base was 7. This little piece is still what number? It's 2. Now, who can tell me what the height is? This requires understanding of a 45, 45, 90 degree triangle. Now the hypotenuse, if I wanted the perimeter, the hypotenuse would be 2 square root of 2. But we're not finding the hypotenuse. We need the other leg of a 45, 45. Now hopefully you remember that when you say 45, 45, that means 2 of the angles are the same, which means 2 of the sides are the same, that are across from the 2 angles that are the same. So if this measurement is 2, you are correct. Your height must also be 2. So these are the little bits and pieces of math and understanding and additive line segment postulate and 45, 45, 90 degree. You're going to have to start recalling all of this material. This is when it all comes together. This is what I say when the metal meets the meat. Okay? So you have to be cognitive of what you're doing. You have to pay attention and you have to think. Now this one happens to be a little bit easier because you now have the height. So if you want to find the area, now I'm just plugging in numbers. So it's 5 plus 7, and I'm multiplying by 2 and dividing by 2. So this is the formula. Area equals height times base 1 plus base 2 divided by 2. Well, here's the neat thing. What happens with these 2's? They cancel out. So your area is 12, and in this case, don't forget, meters squared. All right, good job, and I wish you luck on your work.